What's going on, everybody? Welcome to another video where we are going to use DeltaLake with Spark SQL. Now here's the outline. We are going to add the dependencies to Spark. We are going to use Spark 3.4x, so any 3.4 version is fine. If we head over to the browser in the DeltaLake documentation, under releases, you can find the metrics, compatibility metrics with Apache Spark, and it says the latest DeltaLake version 2.4 is compatible with Spark version 3.4, and that's what we're going to use in our project. So what I have done is in our build.sbt file, we have the dependencies to the Spark version 3.4.1, which is the latest 3.4 version. And then we have the Delta Core dependency, which is going to be of version 2.4. If I hit Command Shift and I, it's going to import these settings into the project. And subsequently, we would like to go ahead, create a delta table from some synthetic data we are going to create in our program. Then we would like to append new rows to this delta table, load these two versions using the version as of option during the delta load. And finally, we will adjust the schema of our delta table by adding a new column using the merge schema option. So let's get started. So heading over to our IDE, I will simply go ahead and create a new Scala object here, which we're going to call DeltaLake. And within that, we don't want to edit here, we are going to have a main method. And we're going to use Spark, so we have to instantiate a Spark session. So in here, we want to have a Spark session, and we're going to import this one into the project, and then we're going to use the builder to instantiate a new Spark session. So the app name, we can pick any string here. We're going to call it Delta Example, and then we have to specify the master as well as the required configuration, and we're going to run it locally with all the cores available. And then we can say get or create. Now, if we want to use DeltaLake together with Spark SQL, we have to add two additional configuration options. All right, so I have copied them. You can see it here. If you run or instantiate your Spark session without these two configs, it will actually print it to the console with an error that you have to configure these Spark SQL extensions to contain the DeltaLake extension as well. And also the catalog, the Spark catalog, has to refer to a Delta catalog. Now we have instantiated a Spark session, and the next thing is to create a new Delta table using our Spark session. And as you may know, we can use DeltaLake using the SQL API, in other words, the data frame and dataset API. So basically the datasets API. So what we want to do is instantiate a new data set from some data that we are going to write by hand, and then write a DeltaLake table from that. So what we need is some data points, and I'm just going to instantiate a sequence here. And I would like to use the type dataset API, and therefore I will define a case class, which is called stock data, which is one object of data we would like to store. And for example, we have a symbol, which is going to be a string that's going to refer to a stock of a particular company. And then we would like to store an open price, which is going to be a double, and a close price, which is going to be a double, and then also a date on which day this prices have actually been or the stock has actually been of that value. Now we have a case class, which will refer to one row in our data set. And now we would like to instantiate some of these. So stock data, the symbol, we are going to use Apple as well again. And the date, for example, would be an SQL date. So we are referring to date and say value of. So we're instantiating a new SQL date from a string, and we say 2023. And then 10:09, and then we need an opening price. Let's say it was 10, and the closing price was 11. And then maybe a second one It's also going to be Apple, and then it's the 10th of October 2023. So the opening price is 11 and the closing price is going to be 12. All right, so from that we can instantiate a data set using our Spark session. So we say spark.create dataset, and here we can pass in a sequence of type T, and type T in our case is stock data. That's what we're gonna do, and in here we're gonna pass in the data. Now we also need an encoder for our data. So the easiest thing would probably to import the Spark implicit, so it can infer an implicit encoder using that. So up here, after instantiating the Spark session, we say import Spark implicits and then all. And now we can see that the error is gone because now we have an implicit encoder for our case class. Now here we would like to save a reference to our data set. And now to create a delta table from that data set, we can simply write this data set as we know using the data frame writer to a delta format. And therefore we pass in as a first option format. And here we can pass in a string. And here we simply say delta. So Spark knows that we want to create a delta table. Now in our project, we have a directory data, and within that we would like to create our delta root directory. Therefore, I would simply introduce a new value here, which is going to be delta root dir, and we just say data and then delta, which is going to be our directory. And going down here, we can now say .save and then the path. And here we would like to use a template. And in here we use the delta root dir and then say stocks. So it would write or create a new directory in our delta root dir called stocks, where we are going to maintain our delta table. Now, as we want to create this table, we have to pass in another parameter, which is called mode. And within the mode, we have multiple options, one of them being overwrite, telling Spark that we would like to overwrite the tables. So here we can see the various options available. So in the documentation here, it says it specifies the behavior when the data or table already exists. In our case, we would like to overwrite. And if we execute this main functionality here now, it will basically create the delta table for us. So let's go ahead and execute this one. All right, now in the logs, we can see that it has completed and it has created Parquet files for us, which is the default file format for delta tables. And it also prints the created schema to the console here. So here we can see we have a struct, which is basically our wrapper object. And within that, we have a couple of fields. So for example, we have the symbol, which is a string, and then the date, which is a date, and so on. And if we look at the files created now, within our data folder, we have now a delta folder, which is the root directory for our DeltaLake. And within that, it has created a directory stocks. And here we have the files containing, the Parquet files containing the actual data. Here in the delta log, that's what DeltaLake actually is. It uses Parquet open file format and also writes log files as JSONs into the delta directory. And here we can see what has happened. We actually shouldn't modify these files, but I've just printed them more prettily here. And here we can see what happened. So he has created a new version, and also there's the schema string for inferring the schema or knowing the schema, which is within the Parquet files without actually loading them. And it has added some data here. So you can have a look if you're interested at these JSON files, which are transactions that has happened on the DeltaLake. Now if I close this again now, we basically have created a new delta table. All right, so the second use case is to add new rows to our delta table. Therefore, I would simply remove this line here, add a new record for our data. So it's the 11th of October, the opening price is 12 and the closing price is 13. And now we would create a new data set from this one and basically append it to our delta table. Therefore, we say, and we want to write this data frame to that same delta table here, but now we don't want to use the write mode override, but rather we would like to use append. And as it has the same schema, we don't have to worry about this one. And what will happen is that Spark will append a new file to our delta table containing only one row and writing a new version. So it increments the version, and we will see how we can access these versions later on. So if I run this, so now it has completed. And if we look at our data now, we see that we have 3 Parquet files now, not only 2 like we had before. And there is also a new transaction has happened. So we have a new transaction file for version number 1, and it says that 1 row has been added. Now we would like to inspect what has been written, and we also would like to access our data for the 2 versions that we have created now. To do so, I would basically remove these lines and show you how to load data from a delta table. All right, now we would like to go ahead and load this data from the DeltaLake or from the delta table. And therefore we use Spark, the Spark session, and .read, which gives us a data frame reader. And here we have also the format delta. To tell Spark we are dealing with a delta table here, so it reads the transaction logs and can have additional functionality, like for example accessing versions. So what we want to do is read our path here again. So we use the same path, so that would be delta root directory and then stocks, and here we have to specify. And here we can specify various options. For now, I just want to show you what happens if we say .show here. And we would expect that our loaded data frame has 3 rows. And actually the columns we have specified in our stock data case class. All right, so now it has completed. We can see that our data set is printed to the console. We have 3 rows as expected. And it's actually the data we have specified in our program. Now if I close this, I also want to show you how we can access version 0, which only contained 2 rows. So therefore we can add or pass in options into this data frame reader. And with the DeltaLake, we have multiple options available. For example, one option which is introduced by the DeltaLake is version as of. And here we can pass in the version we would like to read. Now it would, so let's call option, not options, because we're only passing in one option. So here we would read only version 0 of our delta table. Let me execute this, and we would expect our data set to contain only 2 rows. All right, here we go. It has completed, and as we would have expected, our data set only contains 2 rows for version 0, and if we load version 1, it contains 3 rows. All right, now that's completed. It contains 3 rows as expected. Now another thing I wanted to show you is how we can add a column to our delta table, and therefore we will have to override the schema. So what we want to do is actually to load our data set. So we say Spark. So we say Spark read format latest version. So we remove this one, so we get the latest version, and then the stocks. And we would like to save a reference in our program so that we can use it. And now we would like to say ds with column and then say full name, because before we have only used the symbol name for the stock we're using. That's only example data. So we add a new column called full name, and it has the value Apple Inc. We have to import this one. So our data frame actually not only has 4 columns anymore, but now it has 5. So when we load the table, we can also specify that we don't want to deal with a data frame, but rather with a data set. So we would say as stock data, and it has the encoder implicitly. And then we add a new column, so it will return to a data frame. But now we would like to use this one in the Dataset API as well. So we say stock data v2, and it has an additional column, full name, which is a string. So this one should be also a dataset stock data version 2. Let's call this new DS, which is a dataset. And this we would like to write into our DeltaLake again. Now let's say new DS dot write. That's how we write data to DeltaLake. And then say format should be delta, and then save would be our path again. So let's use this one, 13 lines up, and then this one. Here we go. So it would save our table to this directory. And now we have to pass in some options again, because this would not work, because it would fail, because the table already exists. So first of all, we need to add the mode to be overwrite. So we would like to overwrite the table with the data containing a new column. So we're loading in the entire data, adding a column, and now we would like to overwrite the entire table. And we have to tell Spark, because the schema has changed, we have to tell Spark that it's okay that the schema has changed, because otherwise we would get an error. So we need an option here, one option of key value, and we say merge schema and set it to true. And now it complains that we should name a Boolean parameter here. So what will happen now is we load the entire data set from the DeltaLake, we add a column, and then we overwrite our table to be of the new schema. Okay, let's go ahead and see if that one works. We get an error and it says not found string, so I have a typo here, I didn't see that, so it's string. Let's execute again. The build is fine. So here in the log it actually said it's loading version 1, so you can see all of these statements in your log if you look carefully. And down here it now says that we have a new schema, so new merge schema for root has now a new column full name, which is a string and nullable true. And yes, down here it should have completed exactly. All right, so we have a new column in our DeltaLake, and now we would like to inspect version 2 of our Delta table. So let's go ahead and remove this one again, we don't need it. The difference now is we have done kind of a migration from our data to a new data model by adding a new column. So we read our Delta table now from our directory, but now we have to interpret the data as being of version 2 of our stock data. And if I say ds.show, it should print our data set containing a new column called full name. All right, so here we go. We have loaded the latest version for our Delta table, and it contains the full name. If we wanted to load version 2, version 1, we would get a different result, and we would have to use a different case class. So that's what I wanted to show you about the DeltaLake and how we can use it from Spark SQL. So it has very, very powerful capabilities by maintaining transactions on a Delta Lake or data lake, which is basically only a file-based object store usually. So we have these Parquet files, and additionally it maintains this transaction log which is basically a sequence of JSON files which specifies what has happened in our data. Let's have a look here. So for example, for our version 1, it should say that it has overwritten the data, it's not partitioned, so it's a write operation. It reads the version 1 and creates version 2, and so on. So there's a lot of information stored in these JSON files, which enable us to have versioning and so on in a data lake, which is very, very powerful. And that's what I wanted to show you here. So I hope you enjoyed this video. Thanks for tuning in, and see you in the next video. Bye bye.